All right, so today we have the 2018 Catholic Trials paper, question 21. And in the question, we have this particular graph of gravitational potential energy in megajoules per kilogram at varying distances from the center of the Earth, where this 0 here is the center of our planet. So in question 1, it says account for the shape of the graph and the negative values for gravitational potential energy. Well, the formula for gravitational potential is U equals capital G negative minus mn over r. So that's the actual equation we have here. So accounting for the shape of the graph, the shape that we see is an exponential decay as the radius approaches 0. Okay, and that's to do with our graph there. So what that means is the more or the closer to 0 we get for this r value here, u becomes more negative. Okay, so as we get closer to the center of the Earth, the gravitational potential, or let's just say gravitational potential, becomes more negative or smaller, because if a negative number gets more negative, it's a smaller number there. And what we do know is as the radius is increased, okay, so as it's increased, GBE becomes less negative, and so it becomes larger. So that's what we can analyze from the shape of the graph that we have. Okay, let's go through it. So as we get closer to the center of the planet, so let's say from this point here to down here, you can see that the overall change in the gravitational potential energy has decreased. So, and also because it's becoming more negative. So GPE decreases as you get closer to the center of the Earth. As you move away from the Earth, so going this way back, you can see that the negative value is becoming less negative as you move further and further away. So that tells us that we are gaining GPE, so we are gaining gravitational potential if we're going that particular way, and we are losing gravitational potential if we're going closer to the center. Okay, and then we have the next question. So in this question, it says calculate the amount of work done to move a 600 kg rocket from a point 100 or 12,500 kilometers from the Earth's center to a distance of 50,000 kilometers from the Earth's center. Okay, so we know that the work done would be equal to the change, in this case, gravitational potential energy. Okay, if we want to find the changes, we can write GM that, final radius, okay, minus GM, or minus the initial radius that we have here. So that's what we're going to be doing. Okay, so let's look at how we can work that out. So you can work it out manually using this equation. Obviously, if they give you a stimulus, try and use the stimulus to work it out. So let's look at the points. We have a point of 12,500 kilometers. So about at 12,500 kilometers, we are around this area here. So the halfway point between the 25 to 0. And we get to the 50 mark, which is around about this point here. So we do a couple of estimates. At this point here, we have about minus 34 megajoules per kilogram. And at this point here, we have about 8 megajoules per kilogram. Okay, so this is our final point here. This is our initial point here. Okay, so if we change that around, my final is negative 8 megajoules per kilogram plus 34 megajoules per kilogram. If I swap that around, plug it into my calculator, I get 26 megajoules per kilogram. That was the change I saw there. Now, we are trying to find the work done. So work done is given in joules. But as you can see here, we have kg. So how can I get rid of the kg? Well, this is where we use the mass of the rocket, because what we saw in this graph here, okay, we've actually graphed kilograms in it. So we want to cancel it out to get rid of the kilograms to find our value. So I already know what the mass of the Earth is. That's already taken into account in the graph. If I want to take into account the mass of the rocket, I can do 26 megajoules per kilogram times 600 kilograms. And that is the total work done to move that rocket from that radius of 12,500 kilometers to 50,000 kilometers. If we try and change this into joules, okay, then you should get approximately 15.6 times 10 to the minus, or 10 to the 6 joules there. Let's just make sure we got that right. Not 10 to the 6. We would get 1.56 10 to the 10 joules there. So that's it rounding off. You can, by all means, try and calculate it manually using the change in potential energy formulas there. Numbers might vary, but that's okay. If they do give you a stimulus, try your best to use that stimulus in your calculations instead though. All right? And that's how you do the question for this one.